was that?
Oh, how has he missed that? On match point.
Oh no! What on earth?
After seeing these videos, why do you want to make the same mistakes? You've been searching for a solution, you've practiced for hours, gotten a pro's advice, but you ding-dong! The answer is in calculus.
So we asked ourselves, based on both speed and accuracy when at the net, what is the best volley that you as an individual player can hit? Regular, swinging, or slice?
To verify which volley is best to hit at the net, we had to analyze this on an individual level, as everyone's hitting strengths are often different. So we enlisted Allie Wagner, one of the star players of the tennis team. We set up the data collection like this. We placed Allie at a constant position on one side of the net and situated the ball machine on the middle of the baseline on the opposite side. The ball machine was set to shoot at a constant speed and height, so it took out any human inconsistencies that would have occurred if the ball machine was not used. We then placed cups at a constant interval of 5.7 feet in a diagonal line that connected Allie's position to the target box near the service line. The target box is 28.5 feet away, so we had Allie hit until her shot hit the box 3 separate times. We then analyzed that video later and froze the video frame by frame and measured the height of the ball at each of the cup markers and at what frame the ball was above the marker. We used constant times that were based off of the seconds of the first table and filled in the following 2 shot charts in order to have constant seconds at which to average both the x of t and y of t values. We did this for each of the shots. For reference, this is how we analyzed the video we took. We would pause the video frame by frame, measuring x of t and y of t values at specified seconds or above the cones. We could do this because we put a giant ruler that was proportional on the court so that when we took the video, the ruler that we used in real life would be able to create a line that we could analyze.
We used the makeshift ruler to measure height and the frames to measure time.
When converting frames to seconds, we used a conversion factor of 0.0196. This number came from converting frames to seconds in the actual video and counting how many frames were in a second. And for those who aren't familiar with tennis, this is called a regular volley with topspin and normal racket motion. This is the second shot, and it's called a swinging volley with topspin and forward racket motion that's more extended than a regular volley. This is called a backspin volley with reverse spin and a flat racket motion that causes the ball to move slower once it makes contact with the court on the opposite side, due to the nature of the backward spinning. So overall, to verify the volley, we're taking our 3 shots, getting 3 x of t values and 3 y of t values for each shot, and then for each of those shots, we're going to average those out and get 1 x of t and y of t value for each. The line of regression for x of t is linear, as it is the distance measured in feet, and for y of t it is quadratic because it follows the height in feet of the ball in its decreasing arc towards the target box. Now these are the direct charts of regular shots 1, 2, and 3 along with their averages. We then use these averages to calculate the regular regression lines. XR of t was equal to 54.6093056t plus 1.38131736. YR of t was equal to negative 20.8081149 t squared minus 3.351092092t plus 5.34247.06. These were our charts for our swinging shots, along with the average chart we used to calculate the regression lines. The regression line for xw of t was 54.900038009t plus 1.253330984. The regression line for yw of t was equal to negative 37.48690526t squared plus 5.862008228t plus 4.272641594. These are the three charts for the slice shot and the chart of averages. The line of regression for slice XL of t is equal to 42.646466183t plus 0.9222699027. YLT is equal to negative 14.71201672t squared plus 1.6866005661t plus 4.758373883.
Next, we use the speed formula and for each shot calculated speed at 3 points, 0.025, 0.05, and 0.075. We chose these points because, due to physics, this is where the ball will be traveling the fastest, and also this is where an opponent would attempt to hit the ball back. Here's the data for the values at these 3 points. After averaging the 3 values of each shot, these were our results in feet per second. For the regular shot, 54.88530205. For the swinging shot, 54.96180776. For the slice shot, 42.65123474. So based on the speed factor alone, Allie should strategize by hitting her swinging shot, as it is her fastest volley at the net. But it is also important to consider the accuracy with which she can hit these shots at the target box.
So, in considering the attempts it took to achieve 3 shots that hit the target box for each separate shot, regular led with 35 attempts, followed by swinging with 28 attempts and slice with 23 attempts. Therefore, slice was the best shot based entirely on accuracy alone, as it took the least attempts. So, to factor in both speed and accuracy, which are both crucial to strategy in tennis, we gave each shot an overall rating, where average speed was divided by the number of attempts. So, for our overall rating formula, which is average speed of shot over the number of attempts, we have 2 scenarios that make this equation correct. One is where the attempts are constant, but speed's increasing. Now, for each of these numbers, we get 2, 3, and 4 as our product. And so to get the highest number, meaning the best, gives way to it being a better speed. But it also does the same thing for a low number of attempts by putting that on the denominator. As this is 3, this is 3 over 2, and that's 1. Never mind. That's 3. So you have a higher number over here, which makes sense because that would give weight to a better number of attempts because it's lower on the denominator. So when you put these two together, the highest number is the best because of these reasons. After using these equations on the 3 shots, swinging led with 1.962921706, with slice making a comeback at 1.85440151, despite it having a lower speed than the other 2 shots. And our calculations.
So swinging wins! The nature of the GoPro lens being used was from a fisheye perspective. However, it didn't severely impact our data because it remained a constant variable throughout our footage. Also, due to a tennis shot having even a millisecond difference in overall duration of the shot, the height at what was used as the last point of time where the first shot hit the ground may have had variation over the 3 shots. When the shots pass the marker of 28.5 feet, the box, it registers as undefined because it has already hit the marker. This means that for some of the shots, the last point registers as undefined and the average is therefore invalid. So in order to get the most accurate line of regression, we only counted the first 5 points of y of t to avoid a skew in the line of best fit that occurred, which made the line of best fit more accurately reflect the other 5 points. The line of best fit equation can now more accurately provide the specific segment we need, which occurs in the first instant of the y of t line. In addition, when calculating accuracy, it should be noted that the data might be slightly skewed as Allie's hitting got better after she warmed up. However, we did try to counter this by allowing her warm up for each shot before we collected the data.
And thank you to the following sponsors.
Ooh, you got told.
A bunch of calculus.